In the past half century, humanity has been continuously redefining the bounds of our technological ingenuity. From the development of the smartphone to the advent of decentralized computing systems like blockchain, it seems as if there is no end to our technological progress. But what if I told you that humanity was slowing down? What if I told you that we'd become so good at building computers that we simply couldn't even improve anymore? We can analyze this downfall by using a basic tenet of computing principles, Moore's Law. Moore's Law suggests that every 18 months, performance per dollar of computer chips doubles. This means that computer chips are becoming smaller, faster, and cheaper every year. Due to heat, size, and power restraints, Moore's Law is slowing down. It's becoming incredibly expensive to cool large servers of computers, while the constant reduction of size of computer chips has presented an entirely unprecedented issue. Electrons are exhibiting a phenomena of quantum tunneling as the transistors of the chips are becoming thinner and smaller every year. In quantum tunneling, the electrons have the potential to be on two sides of an electrical field at the same time. This can result in numerous electrical issues for a computer. So, how can we solve this? Some scientists point to reprogrammable chips, grid computing, or clustered computing as possible answers. But, possibly, the most interesting idea involves redefining the entire semiconductor industry. This solution is known as quantum computing. Quantum computing utilizes two main principles of quantum physics: superposition and entanglement. In classical computers, a bit or piece of information can be only 0 or 1. The property of superposition allows a qubit or quantum bit to be 0, 1, or both at the same time. This property is also related to the idea of entanglement, or the fact that the state of one qubit is dependent on another's. In essence, if left unobserved, a qubit's state can be either 1 or 0, but once observed, a qubit's state will be complementary to another, making its pair either 1 or 0.
So what does this all mean? These principles allow quantum computers to perform parallel calculations much faster than an ordinary computer. As each new qubit is added to the system, the processing power of a quantum computer increases exponentially. This can allow quantum computers to solve problems like calculating all available hashes through a nonce generation, possibly breaking blockchain. So which companies have been utilizing this technology? Currently, the field of quantum computing is still in infancy, but some firms have already begun proactively investing in it. IBM, the world leader in quantum computing, has built the first global initiative for quantum adoption. Their program, IBM Cube, allows for public use of their quantum computers through the cloud, and also includes a platform that fosters communication on quantum computing through peer-reviewed publications. Their QuizKit, or Quantum Information Science Toolkit, allows individuals to use an API-like platform to write code in Python and execute it on real quantum hardware. NASA's Quantum Artificial Intelligence Laboratory is also assessing the power of quantum technology on a variety of case problems. Their D-Wave computers have attracted the likes of powerful tech firms like Google for aid in machine intelligence and search or voice recognition.
So what can we expect from the quantum computing in the future? What type of companies will we see rise up in this new industry? The Quantum Computing Report identifies 4 possible business models for the future firms in quantum technology. First, a platform supplier could provide quantum computing technology over the cloud for companies or consumers who just want access to the technology. This is the equivalent Azure-type provider, and IBM and NASA are already pursuing this type of model. Second, a vertical market cap specialist could help consult and help define how a customer could use quantum computing to solve their problems. Third, a quantum under the hood business model could take advantage of this new wave of computing by offering a service for an end application. It's called under the hood because the end user might not know that quantum computers were used, but only focus on the valuable results that it provides their business. Finally, component suppliers could play an integral role in distributing input resources like silicon or other metals to quantum computing companies. As quantum computing moves from being a theoretical idea to an opportunity for massive profit, more and more companies will begin competing for a foothold in this dynamic new industry. It will be incredibly exciting to see how quantum technology will end up changing the world in the future.